Good afternoon, students at home. I hope you are all safe. We are here for chemistry lesson for SS1 class. The topic for today is salt. What is then a salt? A salt is a compound formed when all or part of the replaceable hydrogen ions in an acid are completely or partially replaced by metallic ions or ammonium ion. And what do we mean? We have here a formation of a salt. For instance, if a base, which is sodium hydroxide, reacts with an acid, you have sodium chloride and then sodium chloride salt formed and water. Now, if you look at it, you find out that in this very acid, hydrochloric acid, you find out that the replaceable hydrogen ion there is hydrogen, and in the formation of the salt, you find out that this hydrogen has been replaced by a metallic ion, which is the what? Sodium ion. Hence, you have your what? Sodium chloride salt. So that is what we mean. It is either a metallic ion replaces the hydrogen ion, or an ammonium ion replaces the hydrogen ion. So we have different types of salts. We have the normal salt, we have the acid salt, we have basic salt, double salt, and complex salts. So if we are to look at them one after the other, in the case of normal salt, when we talk of normal salt, we are talking of a salt that is formed when all the replaceable hydrogen ion in an acid have been completely replaced. For instance, in the above reaction or chemical equation, you find out that all the replaceable hydrogen ion in the hydrochloric acid or in this hydrochloric acid has been replaced by this sodium metallic ion. Therefore, this sodium chloride produced there is a normal salt. So we have different examples of normal salt. For instance, like you have seen, sodium chloride is a normal salt. We have potassium tetrasulfate 6 salt. We have sodium triisocarbonate 4 salt. We have aluminum chloride. All these are normal salts. Then we have the acid salt. In the case of acid salt, this is a salt that is produced when there is insufficient base to actually neutralize completely the acid in a reaction between an acid and a base to form salt. So then what does that mean? That simply means that there is partial replacement of the hydrogen ion in the acid. So that is why you have some examples of acid salts, like we have sodium hydrogen triisocarbonate 4. In this case, you will see that if we have more of the base, this very salt will still undergo reaction to give you a normal salt. So the hydrogen ion, all the hydrogen ions there have not been completely replaced. And we have examples of these as potassium hydrogen tetrasulfate 6, like we have the one we have on the board, sodium hydrogen triisocarbonate 4. We have calcium hydrogen triisocarbonate 4, and so on. Then we go to basic salt. In the case of basic salt, these ones are formed by partial replacement of the hydroxide ions in a metallic hydroxide. So when there is not complete the hydroxide ion in a base, when a reaction between an acid and a base occurs, then when the hydroxide ion is not completely replaced, then we have a basic salt. So in that case, there is insufficient supply of acid for complete neutralization of the base. So we have example of such acids as we have zinc hydroxyl chloride. We have magnesium hydroxyl chloride, and so on and so forth. These are examples. If you look at the examples I cited very critically, you find out that these ones are not completely replaced by the acidic radical. That means because of the insufficient acid that was there when the reaction was taking place. Okay, the next one is the double salt. A double salt is a salt that is formed when hot concentrated equimolar aqueous solutions of two simple salts are mixed together in the ratio of their relative atomic masses. I repeat, I say that double salt is a salt formed when hot concentrated equimolar aqueous solutions of two simple salts are mixed together in the ratio of their relative molecular masses. So, what do you mean? When we now see a double salt, we know this double salt by this general molecular formula. We have X2SO4 dot Y2SO4. This is a typical example of a double salt where we can, this our X can be sodium ion or potassium ion or ammonium ion, any monovalent ion. Any monovalent ion can be this X. Our Y can be any of the trivalent or divalent ion like aluminium ion. We have ion 3 ion, and we have even ion 2 ion, but let me say chromium ion and all that. These are the things. So such that if I want to talk about this double salt now, I can rightly say from the formula that I will have something like ammonium tetrasulfate 6 dots, probably ion 3 tetrasulfate, so ion 3 tetrasulfate. Okay, something like this. Ion 2 tetrasulfate. I have ammonium tetrasulfate 6 combining with ion 2 tetrasulfate 6. Then I have this double salt, otherwise called ammonium ferrous sulfate or ammonium ion 2 tetrasulfate 6 salt. So we have them as examples. So let me give you other examples of this. We have this, although it's mostly hydrated, like we have it as dodecahydrate. Contains in it 12 molecules of water of crystallization. Then we have another example, the one that is common to us, the alum. The alum is the common name that it is known, but it is a good example of a common salt. So when we now talk of its IUPAC nomenclature, we talk of it as what? Aluminium potassium tetrasulfate 6 dodecahydrate. Dodecahydrate. So there are examples. There are so many others. So if you look at these double salts cited, you find out that when they are known because of the fact that when they ionize in solution, aqueous solution, you find out that they will produce 3 ions. They will produce, for instance, in this first example, it will produce aluminum ion, potassium ion, and tetrasulfate 6 ion. Then this second one will produce ammonium ion, tetrasulfate 6 ion, and ion 2 ion. So that is what they are basically known for. Then we now go to complex salts. In complex salts, this is a complex salt is a salt that contains complex ions. That is ions that consist of charged group of atoms. So we have example of such as potassium hexacyanoferrate 2. So and others. Then we now go to preparation of salts. In preparation of salt, whatever method that it to be used in preparing a salt, is based on whether that's the salt you're about to prepare is soluble or insoluble. And these are examples of soluble salts that you have here. You can read them up. For instance, all sorts of sodium, potassium, and ammonium, all common triazonitrate 5 salts, most common chlorides. That's the common chlorides as chlorides of sodium, potassium, and ammonium. Now we have under insoluble salt, we have chlorides of silver, that is silver chloride, that of mercury 2, that's mercury 2 chloride, and lead 2, that's lead 2 chloride. These are insoluble salts. And in this case, we equally have the insoluble salts of barium sulfate, lead 2 tetrasulfate 6, and calcium tetrasulfate 6, and all other triazocarbonate 4, except those of sodium, potassium, and ammonium. Those ones are soluble. So now we go into this preparation of, so having known the solubility, the salts that are soluble and the ones that are not soluble, then we go into how we prepare them. In the preparation of soluble salts, we have action of dilute acids or metals. So when any dilute acid like dilute hydrochloric acid or tetrasulfate 6 acid reacts on metals, that what is being produced is what is a soluble salt with liberation of hydrogen ion. That is to say, hydrogen ion is produced when such metal involved are the high positive metals, but other ones, the other things to produce or the other products vary as the electropositivity of the metal decreases. Then we have another way, by neutralization reaction. I want to illustrate this. Neutralization reaction is the only reaction between an acid and a base to produce salt and water. So if you look at the board critically, this is an acid, this is a base, then this is the salt, and this is our water. You're not meeting this for the first time. You have studied that when we did acid last time and base. Now, but why I want you to look at it critically, you find out that this acid reacts with this base to give you sodium chloride. You find out that the hydrogen ion of this acid have been replaced by the sodium metal, and then you have this salt. So, and this salt that is produced, any salt that is produced by this neutralization reaction is what? Is a soluble salt. Then we have action of dilute acid on metals of triazocarbonate 4. In this case, when metals of triazocarbonate 4 react with any dilute acid, there is liberation of salt, water, and carbon 4 oxide. Then we have a direct combination of constituent elements to produce binary salts. That's when two elements react together, they can give you salt. We have instances of such reactions, as in the case of reaction between between ion 2 and then chlorine. Between iron and chlorine, we have iron 2 chloride. So this is a soluble salt. So that they are formed as a result of direct combination of this metal ion and chlorine. Then we have finally the recovery of soluble salts from or by heating it to dryness. That is heating to dryness of soluble salts from solution. So when a salt is dissolved in solution, for instance, our common sodium chloride salt, so when they are dissolved in solution, you can still recover it back when you now heat it to dryness. That is by evaporation. Then we have uses of acids. Uses of salts. Salts can be used for various purposes. For instance, we use it in the preparation of fertilizer. For instance, most times you hear of NPK fertilizer and all that, or there are fertilizer from source of sodium, that is the nitrogen, and then nitrogen, potassium, and and phosphorus. Then we have the salt can be used as laxative. Sometimes if you go out to ease yourself, your bowels may not release you easily, so you may have constipation or something like that. So for you to ease the easy move to ease your bowel for easy movement, you can use laxative. For instance, the salt of magnesium can do that work very well. We have it's used as preservative, as drying agents and antifreeze. Yes, we all know that. For instance, sometimes when we go to market to buy meat and that we don't want to cook on the immediate, and probably our freezing facility is not readily available, you can always pour salt on the meat, and you find out that whenever you come back, you've still found it fresh as ever. Then they are used as drying agents and antifreeze. So when we now talk of these antifreeze, that's most times they are used in lowering the freezing point or to melt ice in freezers. This one is very useful in our domestic chores. Most times when we want to actually bring out our soup from our freezers, we find out that most often it is blocked. Around that freezer, that arena, if you just go there and pour salt, you find out that that container will be released. Or then when you bring out the container, then you can still pour water and pour salt into the water and just drop the container inside that salt water. You find out that with time that frozen food will be released. So we can still use it as baking powder, and then baking powder is a salt, of course. Then we use it in refining, that is in refineries, our oil refineries, in dyeing, in glazing of stone, and so on and so forth. Then we have this deliquescent. There are some of these characteristics of salts that we need to know. That is deliquescent, efflorescent, and hygroscopic substances. All these are some of the behaviors of these. When we now talk of deliquescence, we have deliquescence, we have deliquescent. So students, if you look at these salts, before now you think salt is just only sodium chloride. That's our ordinary table salt. That is it here. But we have so many things that are salt in chemistry. Like this one is now copper tetrasulfate 6. This is copper triosnitrate 5, nitrate 5. Then this one that is deliquescent is our calcium chloride. Then you now look at this. This is our ammonium tetrasulfate 6. Like I said, this is our sodium chloride. All these are salt. If you look at this salt very well, you find out that you have these ones that are being anhydrous, you see, no water of crystallization there. Then this one is a deliquescent substance, because just within a short period I brought it out from the container, you see that it has turned to solution, and so on. And so these are examples of loss. So now you have learned salt, you will know that when we now talk of salt, we are no longer talking of ordinary table salt, that we have different types of salt in chemistry. Thank you. Deliquescence, this efflorescence, hygroscopy, these are characteristics of compounds, mainly salts. And let us look at these processes. When we now have it, if you look at it, I wrote deliquescence and I wrote deliquescent substance, because these two confuse students. Most times when you are asked this in WAEC, you go and answer this, you fail it, even when you're right. So let's look at it one by one. When we now talk of deliquescent substance, you find out that our deliquescence is a process. It's a process whereby some compounds or some salts, well, on exposure to the atmosphere, we absorb water. And this water they absorb, they will dissolve in the water. It's a process. But when we now talk of deliquescent substance, we are talking of those substances that exhibit this behavior. Example of such substances that exhibit this behavior are substances like calcium chloride, we have iron 3 chloride, and we have sodium hydroxide. Okay, for some of you that your mommies prepare soap at home, you find out that when they have this their soda, the one they call soda, when they bring it and leave it for some time, you find out the thing will now turn into solution. So that is the deliquescent substance, and that soda is the sodium hydroxide I just talked about. Then we have the efflorescence. Efflorescence on itself is a spontaneous loss of water by some hydrated salts on exposure to the atmosphere. I repeat, I said it is a spontaneous loss of water by some hydrated salts on exposure to the atmosphere. And then those substances that exhibit that are called efflorescent substances. In other words, if you ask efflorescent substance, you now talk about there are substances that, but when you are now asked of efflorescence, you now tell them that it is what a spontaneous loss of water by some substances on exposure to the atmosphere. Okay, so we have substances that exhibit this behavior. Examples of such substances are examples of efflorescent substances are copper 2 tetrasulfate 6 pentahydrate. You see, it's having water of crystallization. We have another one like sodium triisocarbonate 4 decahydrate. So what actually some of these substances do is that they either lose all their water of crystallization to become anhydrous, or they lose some or part of the water of crystallization to become less hydrated salts. That is to say, I've used this phenomenon now. I'm talking of lower hydrated salts and then anhydrous. When you say that a salt is hydrated, that means it still contains water of crystallization like the one you're seeing, or a lower water of crystallization. But if you have the one, for instance, if this one should lose, if this one on exposure to the atmosphere should lose all the water of crystallization, that it has lost these 10 molecules of water, this one now becomes anhydrous, showing that there is no water in it again. So then we go into hygroscopy or hygroscopic substances. Hygroscopy is a process or phenomenon whereby some substances on exposure to the atmosphere absorb water, but the water they absorb, they do not dissolve in it. Rather than dissolving in it, they will just become moist or they will become sticky. That is what they call anya. So they become sticky. So such substances are regarded as hygroscopy. If you look at it very well, you find that there is difference between these two, but only that in this case, the substance will absorb the water and form solution, but this one will not form solution, but rather become sticky. We have examples of substances that behave that way as your calcium oxide. We have H2SO conc, H2SO4, conc tetrasulfate 6, and so on and so forth. So in general, you find out that in science or in the laboratories, the liquescent substances and hygroscopic substances are considered as drying agents. In the lab, you see them as desiccants in a desiccator, or we either call them desiccants in a desiccator, or we call them dehydrating agents. So, and all the examples that appeared in the liquescent substances and hygroscopic substances are drying agents. But your choice of drying agent will depend on the reactivity of the substance with the gas you are about to dry. If they react, you will not use it. You rather use the one that it will not react. So students, you have questions to attend. You have to state 2 types of salts with examples. You have to use an appropriate equation and illustrate 5 ways of preparing salt by neutralization only. You use 5 appropriate chemical equations to illustrate that. Then you will be able to differentiate between the liquescent and hygroscopic substances. Then you list gases that can be dried using the following: conc tetrasulfate 6, fused calcium chloride, silica gel, and calcium oxide. Thank you and stay safe.